Welcome to another edition of Nye's Notes. And for this one, we're talking about power of a power, and or we can also refer to it as exponentception. This is a screenshot from the movie Inception, and I always use this one as kind of a talking point about understanding power of powers. But then Miss Arch kind of told me that, like, hey, Mr. Nye, like, your kids might not know about this movie because it's 10 years old already. So it's that blows my mind a little bit that it's been this long since this movie came out. So you might not know about Inception. So I might ask some things about why I call Power of a Power is exponentception if you know this movie. If not, then it might not make sense, and I'll kind of recap that as we kind of connect through our next math class. But power of a power, exponentception, connecting to the movie Inception, even though I'm starting to get old man noises and say that, hey, this is 10 years old. It is not a current movie anymore, even though I think that it is. So our first thing is we're just going to jot down the first key concept for this, and that key concept that you're just going to write down is the definition. So you have your definition, power of a power. And then what you're going to write down are just simply the words connected to it. To find the power of a power, multiply the exponents. So it's giving you your shortcut already, but we just want to get this information down first as our first definition. If you need to pause, and if I'm going too fast, hit pause, and then hit play again, and it'll pick back up. Here's an example of us using that concept. So now if we have this idea of powers, our shortcut said just multiply the exponents. And here's why everything works. So I'm going to have you jot down this information to kind of help you understand it. First, we're going to write this equivalently, and we're going to say, okay, well, in these parentheses, I have 8 to the second power. And what that's telling me is I'm going to take these things in parentheses, I'm going to write it 3 times, because I'm taking everything in those parentheses, and now I'm taking that to the third power. So one way that I could write it would be 8 to the second and write that 3 times. 8 to the second, 8 to the second. So now I'm showing that I took everything in that parenthesis, and I just wrote it 3 times, and now I know that I'm multiplying those things together, because it's the third power. It's repeated multiplication. So one thing now that I can do to continue to solve is, well, I know what 8 to the second is. I know that breaks down as 8 times 8. So these yellow parentheses are the same thing as the black parenthesis, just written differently. And so now I can say, well, this is 8 times 8, and this is 8 times 8. So now if we look at the expanded form, we are just really simplifying things down and kind of understanding what's going on here. So now if I look at this chain, I have 1, 2, 3, 4, 5, 6 8s all being multiplied together, meaning that's 8 to the 6th power. We take that back to our original shortcut, and yeah, that makes sense from our shortcut. We just multiply the exponents when I'm taking a power to another power. So I'd get 8 to the 6th because I'm taking 8 to the 2 times 3. And again, this works and is different because I had that 8 squared. And again, these are things you don't need to write down any further. As long as you have this in your notes, this part in your notes, and then this part in your notes to get to that final answer, that's, I think, is what's most important. But I think here we just have to understand that if I'm taking something that is a power, 8 to the second, to another power, I'm writing down everything in parentheses 3 times and then figuring out, okay, well, what does that actually mean? 8 to the second times 8 to the second times 8 to the second, which is 8 times 8 times 8 times 8 times 8 times 8, or 6 8s in total. Our second definition that we're going to put in today puts a little bit of a different spin on the power of a product, the power of a power, and this is called power of a product. So in power of a product, this is your the title of your term. And then here is how to do it. To find the power of a product, find the power of each factor, and then multiply. And we'll go through some exact specifics about what that means. So if you could jot down that into your notes. Again, we have the stop, listen, and write section right there. I'm going to keep moving forward, but again, the perfect part of the video, pause it, hit play, and it'll pick up right when you're ready to go. So here we're going to talk about some differences, because when we just took our quiz, we had some people utilizing some of these things differently, even though we have some different ideas in play. The differences are the differences are the uses of your parentheses. Here in the left side, 3 8 third, we remember that we have something mashed. So we have 3 times 8 to the third power. So here, the third power is only connected to the A. meaning that I'm taking the number 3 and I'm multiplying it by whatever a to the third power is equal to. The difference here, and again, this is just the listening section, you have to write this down. The difference here is our grouping symbol, parentheses. Our parentheses are saying, hey, take everything in parentheses and take that to the third power. So now the third power is connecting to everything in the parenthesis. It's saying take everything in there to the third power. So that's why we have 3a times 3a times 3a. The difference here for our final answer, I have now, if I think about this in expanded form, 3 times a times 3 times a times 3 times a, I now have 3 3's and 3 a's. So when we took our parenthesis to a power, I took every factor to that power. When we started over with this one here, let me get rid of some of this extra gunk. When I started this here, I didn't have any parentheses, so now the power was just connected to the a, because it wasn't grouping everything together and saying take everything in this group to the third power. It's just taking a to the third power. So my final answer here would just be 3a to the third power. The difference, these are not equal to each other because I have here 3 to the third power times a to the third power. Because once I took everything in parentheses to the third, I found out, yeah, I have 3 a's and 3 3's. Here I just had 3 a's on this side, just 3 a's. So that's a major difference, and that's kind of how we're going to apply some of these things. So now for our example here, we have a product, 9j to the 5th. Again, remember, a product is just an answer to a multiplication question. We have a product, and we're taking that to the power. So now because of these parentheses in here, these parentheses are saying, okay, take everything in parentheses to the third power. Remind yourself that in the parentheses, we have a multiplication problem, 9 times j to the 5th. That means I'm taking everything in there to the third power. So now I'm taking 9 to the third power and j to the 5th to the third power. So 9 to the third power would be 9 times 9 times 9. J to the 5th to the third power would be j to the 5th times j to the 5th times j to the 5th. And if you could put this expanded form down in your notes, this would be super helpful for example number 2. So this shows that we took 3 9's, or 9 to the third power, and we're multiplying it by j to the 5th to the third power, so 3 groups of j to the 5th. If I expand this out, I know that that's j times j times j times j, and I just repeat that 3 times. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And now if I'm looking for a final answer, I'm saying, okay, well, how many j's do I have? Well, here I have 15 j's because I had 3 groups of 5 j's. So if we go back to our actually, let's get our final answer first. Our final answer is 9 to the third times j to the 15th once we take this and expand out. So here's our final answer. Our shortcut reminds us that when we're taking exponentception or powers of powers, I just multiply. 5 times 3 is 15. When I didn't have an exponent connected to my 9, or if we think about it with that invisible number 1, because that's like 9 to the first, my pattern still holds. I still multiplied, and I still got 1 times 3, which is 3. So now we're taking a product to a product because it's a multiplication problem in the parentheses, 9 times j to the 5th. And so here I take every part of that, every factor of that product, 9 to the third power and j to the 5th to the third power, to get a final answer of 9 to the third times j to the 15th. This is just a general reminder, going back to those ideas of our factors, that when you have something that's mashed together, that means to multiply it. So now this final answer, remind yourself, is 3 times a to the third times b to the 4th. And since I didn't have any parentheses around or near those exponents, I know that it's just a being taken to the third power and just b being taken to the 4th. It's not any further explanation of products or powers or anything like that because there are no grouping symbols and there's no exponent on the outside. So just remember that when we have things mashed, that means we're multiplying. So now if I even go backwards, and again, this is just a listening section, so that's just fine if you don't write this down. But what if I take this now to another level and I say, okay, let's take everything in parentheses and let's take that to the second power. Now if I remember that we have this mashed as multiply idea, that means I have to take 3 to the second power, a to the third to the second power, b to the fourth to the second power. Well, my final answer, let's get a better color than just white. I'd have 3 to the second power times a to the third to the second, which is 6 total a's because I multiplied my exponents. And then I have b to the fourth, that being taken to the second power. So that'd be like b to the eighth. And we can expand those things out by saying, okay, remember b to the fourth is 4b's, and now you're taking that to the second power. So now you have another set of 4b's that you're multiplying all together, 8 total b's that we have there. So that's where I get that final answer of b to the eighth, a to the sixth, 3 to the second. For our final dad joke of this video, this was submitted by Dylan Sirwa, and if there are other people that sent this to, I'm sorry, when I was going back through my emails, I saw it from him first. Why did the Scarecrow win an award? Got this fancy Scarecrow award. Why did the Scarecrow win an award? Well, because he was outstanding in his field. Outstanding in his field. Cue the groans, cue the eye rolls. Happy mathing. Use this video to help on your assignment. Post it in Canvas. I'll see you later. Come to me with questions if you have them.